Welcome back to my channel. Thanks for tuning in. In this video, we're going to talk about scientific notation. I hope you're having a great day. Let's get started. So what is scientific notation? Scientific notation is a number that is expressed in this form, a times 10 to the nth power, where the absolute value of a is between 1, it could be equal to 1, but less than 10, and n is an integer. So what is an integer? Your integers are -3, -2, -1, 0, 1, 2, 3, and so forth. And you can keep going in that direction. So n is an integer, your exponent is an integer, and then this number has to be between 1 and 10, and it can equal 1. So that's when a number is expressed in scientific notation. Now, most of the time in science, scientists work with numbers that are extremely large, or extremely small, and so they use scientific notation as a simpler way to express a number that has lots of zeros, and so you'll see it used in science a lot. So it's important in math that we know how to appropriately express and read numbers that are in scientific notation. For example, here is a number expressed in scientific notation. This is 3.19 times 10 to the second. This number is between 1 and 10, and this exponent is an integer. So this is a scientific notation. Now, what does this mean? This number tells me how many times I move the decimal place. So if that number is positive, so just like on the number line, my positive numbers go this way, my negative numbers go to the left. So if that number is positive, that means I move my decimal place to the right. So that number is positive. So for 3.19, I will move this decimal place to the right 2 times. So my decimal place will go here. So this is equivalent to 319. If I had 3.19 times 10 to the -3, that number is negative. That means I move my decimal to the left. So I'll move that decimal to the left 3 times. That's 1 time, that's 2 times, that's 3 times. So my decimal will go here, and everywhere I have a loop is where a 0 would go. So, and actually I didn't want to do it on this one. So 3.19, move the decimal place 3 times to the left. I will have a 0 there and a 0 there. So this is equivalent to 0.00319. So that's how you take a number that's written in scientific notation and just write it out in its written form. All right, let's look at some examples. So starting with example 1, we want to take each of these numbers. I have 3 different numbers, and we want to write them in scientific notation. So in order for our first number to be between 1 and 10, your decimal place is going to go in the first spot. It's going to go right after the first non-zero number. Alrighty. So if we look at this, the first non-zero number is 9. So your decimal should go right there after the first non-zero number. So this will be equal to 9.3. So all I'm doing is I'm writing the non-zero numbers, but now I have to figure out how many times do I need to move the decimal place. So my decimal is here. How many times do I need to move the decimal place to get there? So that's 1, 2, 3, 4, 5, 6, 7. So I have to move the decimal place 7 times to get there. So that would be times 10 to the 7th power. All right. So now how do I know if it's a positive or a negative power? So positive powers represent bigger numbers and negative powers represent smaller numbers. So remember, I told you earlier, so this might be a little confusing. If you look at the number line, if your exponent was positive, that means you move the decimal to the right. If your exponent was negative, that means you move your decimal to the left. So if I was to read this backwards, this is 10 to the 7th. 7 is a positive number. That means I will take this decimal and move it to the right 7 times. So it could get confusing depending on which way you're going. But if you remember, your bigger numbers have positive exponents, your smaller numbers have negative exponents. That'll kind of help you keep it straight when you're writing it out. Alrighty, so this is 63,200,000,000. So my decimal is going to go after the first non-zero number. So 6 is the first non-zero number. So my decimal is going to go here, and I'm going to write every non-zero number. So 6.32. And now I need to figure out how many times do I need to move the decimal to get here. So if my decimal is here right now, how many times do I need to move it to get it right here after this 6? So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means this is times 10 to the 10th power. So this was my scientific notation for the first one. Here's my scientific notation for the second one. And now for this one, so this was a bigger number, so my exponent was positive. All right, for this one, my first non-zero number is 4. So if I write the decimal after the 4, this is going to be 4.62. How many times do I need to move my decimal to get there? I need to move it 1, 2, 3 times. But this time, this number is smaller. You see, this number is less than 1. So that means my exponent is going to be negative. So this is 4.62 times 10 to the negative 3. And if you want to test it out, negative 3 would mean you would move this to the left. If you move it to the left 3 times, you should have a decimal and 2 zeros. Is what we started with. So this is how you will take numbers and express them in scientific notation. So now in example 2, we want to actually work opposite. So in the last example, we took numbers that were in standard notation and wrote them in scientific notation. So now we have numbers that are in scientific notation. We want to write them in standard notation. That's how you normally see a number. So if we start with this first one, 6.2 times 10 to the third. So we'll start with our 6 and our 2. Our decimal is here. Since that exponent is positive numbers go to the right. That means we want to move this decimal 3 times to the right. 1, 2, 3. So our decimal will now go here. And everywhere I have a loop, that's where a 0 would go. So this is equal to, just in case you can't see that number, that's 6,200. So that's what 6.2 times 10 to the third is equal to. All right. So for this number, 4.283. Times 10 to the 6. 6 is a positive number. Positive numbers mean I'm going to move my decimal to the right. So again, this is when I'm going from scientific to standard notation. And remember, positive exponents represent bigger numbers. So that means I should be making this number larger. So I'm going to move this 6 times. 1, 2, 3, 4, 5, 6. So my decimal is now here, which means I have 3 loops that are empty. So 3 zeros should go there. So this number is 4,283,000. And then this very last one, negative 7.04 times 10 to the negative 3. Negative numbers go to the left. So that means I'm going to take this decimal. So 7.04, I'm going to move this decimal to the left 3 times. So 1, 2, 3. My decimal is now here. And because that's a negative number, I have to keep the negative in front. So this is equal to, and I'm just going to put a negative in front, another 0 in front, negative 0.0074. So this is how you will take numbers that are in scientific notation and express them in standard notation. If the exponent is positive, you move the decimal to the right. If the exponent is negative, you move it to the left. Remember, positive exponents represent bigger numbers. Negative exponents represent smaller numbers. So this has a negative exponent, that's a smaller number. Positive exponent, bigger number. Positive exponent, bigger number. In the last 2 examples, we're going to look at how do you perform calculations with numbers in scientific notation. So for this first example, which is example 3, but the first one for calculations, we want to multiply 7 times 10 to the third times 5 times 10 to the fourth. So we have 2 different numbers in scientific notation and we want to multiply them together. So the first thing I want to do is I want to multiply my numbers together, the 7 and the 5, and then I want to put my 10s together. So 7 times 5 is 35, and then this will become, so now this goes back to our properties of exponents. You have 2 exponential expressions with the same base, but different exponents, and you want to multiply them. So you will combine them by adding the exponents. So you will add the 3 and the 4, and it becomes times 10 to the 7. Now there's one thing to note here. A number is not in scientific notation unless this first number is between 1 and 10. And 35 is actually bigger than 10. So what we need to do is convert 35 to a number that's between 1 and 10. So the way we do that is we'll put the decimal here. So I'm just going to, on the side over here, 35 is equal to 3.5 times 10 to the what? So the reason I put 3.5 because I put the decimal after the first non-zero number. So in order to make 3.5 35, I will need to move my decimal to the right 1 time. So this will be times 10 to the first power. So 35 is equal to 3.5 times 10 to the first, and I still have the times 10 to the 7th. Again, in order to combine these two, I would have to add the exponent. So this would be 3.5 times 10 to the 8th. So that will be my final solution to this calculation. And if I had to, I could write that out as move my decimal to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. That will be 1, 2, 3, 4, 5, 6, 7 zeros. So that will be a comma here and a comma there. So 350 million. So that's equivalent to 350 million. So that's how you will perform that calculation. And for this last example, we want to perform another calculation. This time is division. So it'll work the same way as the last one. You want to combine your two numbers together. So 4 divided by 2. And then you want to combine your tens together. So 4 divided by 2 is 2, but then in order to combine these, you have two numbers with the same base, different exponents, and you're dividing. So in order to combine those, you have to subtract the exponents. That goes back to our properties of exponents, the quotient rule. So this would become 10 to the negative 5 minus 3. Negative 5 minus 3 is negative 8. So this would be your final answer, 2 times 10 to the negative 8. That's your answer in scientific notation, and if you had to put it in standard notation, here's your decimal. Negative 8 means go to the left, so you'll move that to the left 8 times. 1, 2, 3, 4, 5, 6, 7, 8. That means you will have 1, 2, 3, 4, 5, 6, 7 zeros. So if I was to write this more clearly, that would be 0.1, 2, 3, 4, 5, 6, 7 with the 2 at the end. So that would be this number in standard notation. And so this is how you would perform this calculation. This is scientific notation. We looked at what is scientific notation. How do you go from standard form to scientific notation? How do you go from scientific notation to standard notation? We also looked at how would you multiply two numbers in scientific notation. How would you divide? If you have any questions whatsoever, put them in the comments below. If this video helped you at all, hit the like button, and I'm sure you have already, but if you haven't, make sure you hit that subscribe button. Thanks for watching, and I will see you in the next video.